Hi guys, and welcome to another exciting episode of Journey to Journeyman. This is episode number 25. And in this episode, it's all about fixing parts and making parts for the Atlas horizontal mill, starring the South Bend 10K, and has a supporting role of the Atlas horizontal mill, actually making parts for itself. And I would like to first start off with a huge shout out to Captain McFingal, who sent me a viewer appreciation gift. We'll do that and we'll get on with the machining. I hope you enjoy this. Well guys, once again some excitement. A viewer of mine, Captain McFingal, messaged me and wanted to send me a gift because he likes my channel. I'm shocked at the generosity of honestly complete strangers. I don't know how it is in the rest of the world, but in the US we tend to focus on bad news, but I don't tend to focus on that. I focus on the good stuff, and this is this is incredible. So anyway, let's take a quick unboxing of it. Can't thank him enough for that. Captain McFingal, that is. And let's take a look. KBC Tools, so you know it's got to be good. It's tools. Awesome. Awesome. We got a deburring set for, let's see, steel, aluminum, or plastic. Excellent. And we got oh wow, that's carbide, I do believe. End mills. Let's take a quick look-see. Sure enough, holy cow, I knew that was heavy, and I hear that they say carbide is heavy. So wow, carbide end mills and solid carbide. Wow, that's first ones I've ever had. And we have another solid carbide end mill. Holy cannoli. They're right, it's heavier. It's much heavier than high-speed steel. Check that out. Wow. And this other one, a little one. Got to be real careful with that. Awesome. And the KBC catalog. Fantastic. Thank you, Captain McFingal. I really appreciate that. And these will be used. Thanks again. And this, ladies and germs, is the real deal. This is going up on the wall. This decimal equivalent chart and tap drill size. Wow, I dig this. That was in the in with the catalog. So this is just incredible. Thank you. All kinds of cool stuff in here. Check those guys out. I got to figure out how to hold this, whether the 4-jaw or flip these jaws around. But in the meantime, I'm going to work on that washer. And here's a piece of aluminum that I got from pop cans. I'm going to make a little mandrel. Now this is kind of wild. I kind of eyeball that and got it close. So I was trying to leave it a little fat, but I didn't. So I'll take it down and keep facing that until I get a register that's going to be perfect on there. Okay, so that fits on there nice, and I'm going to try to use super glue, and I need to cut a little bit of relief so that I can measure this and the thickness as I cut the thickness. And now that I got the mandrel to the right size, what I'm doing now is putting super glue not only on the mandrel, but on the piece itself. And then I'm going to hold it in place until it gets nice and firm, and then wait a little bit longer to make sure it's nice and tight before I start the machining process. Now this is just a store-bought washer, so I want to get one side of it nice and true and flat. Then I'm going to flip it around, and that's when I'll machine it to the correct total thickness. Well, now that the side is flat, I'm going to go ahead and get it off of here using some heat to release the super glue. And important safety tip, don't grab it right after that. All right, so that's that side. That's giving a real good, nice cut on there. Now I'm going to knock that super glue off of that one. Get it super glued back on. And hopefully that little run out that I saw, that'll knock that run out off of there. So let me get this cleaned up and glued back on. Now because that super glue is on there, I'm going to go ahead and machine a new flat face on there. And that's just to make sure when I put the new super glue on with the new face that everything is nice, flat, and true. And now we super glue it back on and get it cut to thickness. Okay, I didn't bother to get the glue off it because I'll machine that glue off, but let's try it again. It's got a little bit of some run out in it, so I'm going to take that back off of there and try to re-glue it. And I did re-glue it, and I did get it nice and true onto the mandrel again.
Everything that keepeth upon the earth wherein there is life, I have.
Now after measuring, I take my time and I'm slowly getting it to the correct thickness. And I'm very, very patient right now. Now somewhere in this sanding phase, I start losing patience and I overdo it and overshoot my dimension. All right, let's try this again. I went and made a little washer that was missing. So let's get that on. Now it does fit, guys, because this was the third one that I made. All right, guys, what I did is squared this off with the chuck. So I started off by squaring this tool post off with the chuck. Then I took and put my finger here and put that on there and brought it up to the jaws and then opened the jaws. And I got it running pretty true. So I'm going to shave off 150 thousandths from that and we should be good to go. Now I know that was a little confusing, but all I was trying to say was I was getting everything lined up and square in the chuck before I tightened it. And I'm doing very, very light cuts because this is held in there. I don't want it too tight because I don't want to mar the finish. It took me several days of thinking on how to hold this without damaging it, but it was pretty straightforward once I knew how to hold it. I was excited to find out when I was doing my restoration on my horizontal mill, my Atlas horizontal mill, that the milling attachment that I have on my Atlas 618, the drawbar, would actually fit on the horizontal mill. That was prior to me putting the cover on. Well,
Once I got the cover on the Atlas horizontal mill, I realized the drawbar was just not long enough. So I had to make an extension onto that. And it looks about a couple of inches that it needed to be extended. Now this threading that you see me doing, that's real time. I'm not a pro, I'm just a beginner. There's no way I should be going this fast. And that later turns out to bite me. Now right here, I forget to wind the cross slide back in, and so I had to just back it out and redo it. And there's a couple things I got going on wrong here, guys. One is I got the compound on the wrong angle, and two, I'm just going a little too fast. And I mean too fast for my skill level, that's all. Now I realize there's a little sawtooth going on, so I try to fix it by using a die. So I'm having a little trouble getting that started, so I decided to put a little chamfer as a lead in. Alright guys, I got some success. I tried to get the die on it and I couldn't, so I went back to single point. But here's what I started doing. I saw that it was starting a sawtooth, so that the compound must have been at the wrong angle. So what I started doing is just very light plunge cuts. So I would, instead of feeding in this way, I just feed in here, cut, zero it out, add 5 thousandths, and just keep cutting like that. And got it. So I'm going to file the tops of the threads and call it done. Now I did bugger that up down there with trying to use the die. So, alright. Now I got to flip it around and do the same thing. So now that the external threads are done on this side, I flip it around, and now I need to drill and tap it to get internal threads on the other side. Well, a confession, guys, this did work. However, it was too short. So here I go making another one, and I'm just playing around with surface finish right now. Okay. Alright, that was a little aggressive on that part there, but wow, that gives a great finish with a high rake. So I'm going to have to learn how to grind with a high rake. So I got a little bit of concern because I had some issues with sawtooth and my last time I tried to do the single point threading. So I set it up again, slow everything down, and this time it worked out absolutely perfectly. So just looking at these threads, they look super good. So the first thing I want to do is try it out with a nut. It was a little snug, so I did a spring pass or two. And now I wanted to try it out with the collet. Pretty proud of that. That turned out really nice. Now I need to just do a couple more spring passes and call that in done. Alright, after a couple of spring passes, boy, that fits on there nice. Alright, so actually I'm really proud of this because, man, when I did the other threads, I messed up and made them that sawtooth again, but this one really worked out. I had the compound on the wrong angle, just by a couple of degrees, and I was able to fix it by using the die over it, but this makes me feel good that I can single point. So, happy, happy, happy. Now let's continue with this thing. Now, cut that off 4.5 inches. Alright, now we'll face, drill and tap that baby. I would say I'm getting pretty good at my machining because I started off making 3, and on this one I only had to make 2. So in my opinion, that's winning. That's progress. Now here it is going on to the drawbar, and when I first made the spacer for my Atlas 618, there were some mistakes that I made, but I kept them, and it turns out they're great spacers, almost perfect with all of those on there as a spacer for the mill. Now there's a wobble in this countershaft pulley, so I decided to make a new countershaft. During the restoration of this mill, I noticed that that countershaft was pretty chewed up, and I knew eventually I'd have to make one, and now I decided to make one. Now I have quite a bit of drill rod, and this one was the exact diameter to fit everything. It's the exact diameter of the countershaft, so I'm going to make the countershaft out of this drill rod. So I need to get it measured and then cut off and then put in the lathe. Now the milling portion, the lathe portion of this is basically just squaring off the end and putting a chamfer on it. And I cut it about a little over a 1/16 too long so that I could cut it, face it right to the correct length. So this is the very first time that this mill is going to be making a part, and it's making it for itself, and it's a very simple thing of just putting 3 flats onto this bar. So now I put the old countershaft back in, get the pulleys on, and start milling. Now here I'm just using an end mill in a collet. I'm going to use that drawbar to make everything nice and tight, and then I start the milling. I started getting vibration, and I didn't know why it was getting that vibration until I figured out that the bull gear pin had come out and that was vibrating. This cutter is choked up on it, and the problem is this is as far as this will go in now. I didn't realize I just bottomed out on the on that axis there. So what I'm going to do is reposition the cutter out a little bit more, have a little bit more stick out, but instead of trying to rearrange these blocks. So let me try that and see what happens. And yes, for those of you who are real observant, this is a smaller diameter end mill. I thought that maybe that large diameter was causing a problem, but it was, like I said, the bull pin was loose. But this cuts quite nicely. Now once I have the depth on this first one, I just slide it over and do the exact same depth on the end of it. And I'm not making mine as wide as the original ones. I just decided to make it as wide as the set screw. Now here I'm using my machinist square and a 1-2-3 block, and this will get it pretty much 90 degrees. I need 2 of the flats 90 to each other, and this will get it close enough for me. And once again, once I figured out that that bull pin had loosened up, this thing mills really nicely. Ta-da! And now I just need to deburr it and clean off that bluing. And here she is. I think it looks quite beautiful. Now, honestly, guys, it took me several times to get the shaft to fit because I had to really get it deburred because it was such a nice snug fit. It wouldn't go in unless it was deburred. And now, guys, I'm so excited, and it still wobbles. Well, I was hoping that would stop the weeble wobble because I thought that this was getting on there wrong, but looks like it just might have, the pulleys might be a little bit off. So, we'll figure that out.
Well, guys and gals, I'd like to share a couple of lessons learned again. First of all, when you're single point threading, make sure you got the compound at the correct angle. I've done this a couple times where it's off a little bit and you get that sawtooth pattern in the gear. So make sure you have that set correctly. And I was starting to wonder if I knew how to single point thread, which I'm a beginner, but it just was messing up so much, and I looked at it and sure enough the compound was off. Once that was set, I could really do some single point threading, which was extremely rewarding. Also, don't think because you watch Adam Booth, who's an absolute pro at doing that, and he can do it at 100 miles per hour, don't think that as a beginner that you can do the same thing. I tried that and ended up breaking my insert because I jinked when I should have jibed. So anyway, as a beginner, take it slow. Like I said, you can watch Adam Booth 100 times and that doesn't make you Adam Booth. So, and also, how many times have I said measure twice, cut once? Had to relearn that again. I had to make my washer 3 times because I keep overshooting my dimension. I'm very patient right up until the end game, and then I get too impatient right there at the end and do too much and overshoot dimensions. So measure twice, cut once. And also, once again, I'd like to give a massive thank you, that is, to Captain McFingal, who sent a generous gift. I can't thank you enough for that. I really appreciate that. I will get use out of it. The reason I didn't use it in this episode is because I tend to go ready, shoot, aim. And I don't want to do that on this. I want to make sure I use those things correctly. So I have to do a little bit of research on those carbide 2-flute end mills before I use them. But I will definitely be using them. And thank you again. Thank you all for watching. I hope you enjoyed this episode. And I hope to see you on the next Journey to Journeyman.